Welcome! This is the Bentley WaterCAD's interface, simple and clean. One of the features is that you can input map contours or DX files. New, create new file. Select the location of the DX file from AutoCAD. After that, OK. Click the zoom extend. Also, you can input images from maps. Let's try. Now we will do a simple pipe network design and analysis. The layout below is that the proposed used educational camp, part of which will receive its water supply from an overhead tank. You are to design the water distribution system for the subdivision. The tank from which the subdivision will be fed has bottom and top elevations of 700 and 730 feet respectively. This is based on average daily demand of 40 gallons per minute. And here's the detail for the lengths of the pipes and elevation of the junction.
So before we begin our project, we need to first define our prototypes. In order to do so, we need to go to View tab, Prototypes. Then the prototypes needed are the pipes, junction, and tank. Right-click pipe, then New, Junction, and tank. In order to edit the properties, we can just double-click it. And since this is our first project, we have no failure history. And the diameter is 6 inch. We just leave it as default. Then material, we'll change this to PVC. Here, as we can see, we have the default values for the Manning's N, Helsian-Williams C, Young's modulus, and Poisson's ratio. As user-defined length, we'll change this to true since we are using schematic. The check valve, we have no check valve, so let's just leave it be. And other inputs will be as default. Next, we go to junction. We'll change the demand collection and we change it to 40 gallons per minute as stated in the problem. We just need to right click this demand base to global edit and change this to 40 in order for all the junctions to input 40 gallons per minute. The elevations will be edited later as we go through the project. Next, we go to tank. Same as the demand collection on the junction, we need to change this to 40 gallons per minute. Right click, global edit, and 40. If you have different units, we can change this by right clicking, units and formatting, then unit. Let's say you have liters per day, or per minute, or acres feet per hour. This depends on your project. Let's click OK. Same as the elevations, we can edit this. Same as the elevation, we can edit this as we go through the project. Next, we need to add background layers. Okay. Right click, new, then file. Choose. The coordinates, we'll just leave it be for simplicity. Now we are ready to draw our pattern for the project. First, we need to have tank. Let's say we just put it here. To edit the scale, we can just go to Tools, Options, then Drawing. Symbol size multiplier, let's say change it to 3, then 3. Now let's draw our pipes. Now that we are done with our pattern, we can delete our background layer. Next, we need to define the elevations for pipes, junctions, and the tank. In order to do so, we need to go to View, Flex Tables. And first, we need to define the pipe table. Next, we go to tank. For the minimum elevation, you can say it's 680. Then initial, as per the problem states, 700. Then maximum, 730. Then we'll just close this. Since we are finished inputting our elevations, we can now validate our project. As you can see, there are no problems found. Next, we can run our project. Now that we have our results, we can now answer the following questions in the problem. Pressure at junction 1, junction 2, junction 7, the hydraulic grade line at junction 5, velocity in pipe 1, pipe 6, the discharge in pipe 2, and pipe 10. In order to view, you just need to go to View, then Flex Tables. First, we need to answer pressure at junction 1, junction table. The pressure at junction 1 is 33 psi. Junction 3, we have 59 psi. Then junction 7, we have 59 psi. The hydraulic grade line at junction 5 is 696.23. Next, we have velocity in pipe 1. Go to pipe table, then the velocity pipe 1 is 3.63 feet per second. In pipe 6, 1.63 feet per second. The discharge in pipe 2 is flow, then 136 gallons per minute. And the discharge in pipe 10 is 40 gallons per minute. That's all for our pipe network. Thank you.
I'll be showing to you on how to optimize a pipe network system using WaterCAD's Darwin Designer optimization tool. Now, let's go to the WaterCAD application. Here's an example of a pipe network system. Now, let's go to the flex table. For the details of the pipe, click the pipe. Now, the given diameter, 150, and material of cast iron and PVC. Now we will try to optimize this system using Darwin's Designer tool. The Darwin Designer tool is located at the top left corner at the analysis. Click the Darwin Designer. Now we will create a new designer study. We can rename it however we like. Let's say simulation. So that we will create a new event. We can rename it however we like. Also, these are the factors that the tool will use to optimize the system. Start time, design time, demand alternative, demand multiplier, minimum pressure, maximum pressure, minimum velocity, and maximum velocity. Let's say 240 here. 50, 0, let's say 500. Now we'll go to the design groups. We'll select here the pipes we want to design. I will select all. I will go to the cost and properties. We'll create a new design option groups. Let's say repeat modes. Now on the material column, we can select the material that we want to use for our design. Let's say ductile iron. Now on the right is the properties of the material. Select. Okay. One of the beauty of WaterCAD is that you can easily copy paste data from Excel. Now let's just copy. Selected that. Copy. Space. So cut the price. My font to the book plus the text. I will copy property. Now on the design type, you can also change the objective type. You can also maximize the benefit, minimize the cost, or multi-objective trade-off. You can put also your available budget. Now, now we go back to the design event tab to define the selected pressure, bounding overrides, floor constraints, and demand adjustments. I'll just put pressure constraints as an example. You can select junctions that we will define, but I'll use all the junctions. Check for that. Now we will add the run command. Now we'll go to the design group. We'll now put the selected 5 choices. Then you can also copy and paste. Control C. Control V. Now on the option tab, you can also modify the GA parameters, the max trials, non-improvement generations, etc. Let's say 250 here. 500. Now, after that, we will now click compute. And the Darwin Designer optimization tool will now try to design the network system. Now the tool gave 3 possible solutions to minimize the cost using the selected material, which is ductile iron. You can now see on the 2 tables a decrease in the diameter in some of the pipes to minimize the cost. And that ends our simulation. Thank you for listening.